Hey guys, how's everything going? This is JSer. In this video, I'm going to try to solve another question. It's infinite scroll. So I am asked to implement an infinite scroll. How should I approach this problem? Well, I think I should follow the 6 steps which I listed up in my previous videos. So the first one is to it should be define it, because this is not a product design. There's no such thing as big questions here. I'll just say just define the MVP now. So our goal is to I'll make it bigger. Okay, our goal is to create a scrollable list, right, with a bunch of items. And this list could able to render full viewport, render items, elements in full viewport as if all are rendered, right? Yeah, so to the user, it seems that every atom is rendered, but actually it's not. We're just rendering the minimum, right? We render the minimum nodes elements as possible, right? Okay, so and for this list, we should support a top and head, right? Top and bottom, right? And for bottom, it should be able to connect to data source. So this is MVP, right? For these, I think I'm going to cover. Maybe the last one is I don't have time to this. Okay. Anyway, let's continue. So I'll have a general picture. It's what? So let's do some analysis here. Only for this video, I'm going to show you what the infinite scroll is, right? So this is a Twitter. You see that this is the list. No matter how I scroll, you see the list items will be only this, it will not overflow. Like it will, you see, the items at the top will be removed, right? Yeah, you see, only enough items are there. All right, but if I scroll up, if you scroll fast enough, you will see some white screen, and now the Twitter is trying to append the old items and remove the items at the bottom, right? So pretty straightforward. If you think of like a sliding window, yeah. Okay, let's draw some big pictures here. Okay, so I should say that this is the contents. This is a list, right? I'll say it's a very long list. Okay, and this is a okay here. This is the contents area. And there's a viewport. I should say something with different color. This is the viewport. Okay. This is content area. This is viewport. So the scroll actually happens here, right? Now this is not a viewport, but it actually should be the container. Scroll container. How can I? Okay, this is scroll container. How should I? Okay. I cannot Add new line. Command enter. Okay. So this is a scroll container. This is a contents area, and there's a we actually need to fill this scroll container with minimum elements as possible, right? So of course we should add the element here, element 1, right? And then element 2, item 2. Here it should be item 3. Item 3 might be this big. Okay, I move this to front with the opacity of this color. Okay, so actually it covers half of the item 3. Cool, something like this, right? So if we meet some case like this, I think we should remove the DOM nodes in item 2, right? Just to remove it. I'll give it a color set, it's black. Okay. Remove it. So now we scroll these contents, and whenever we scroll, we should update the items, right? Based on the scroll container. Well, let's suppose we add a buffer. Okay, the buffer is, suppose the user will scroll like with a fast speed, give some inertia. So I think half of the scroll container above at top and half of the height at bottom, right? Yeah, so it means the here actually we need to give this as a color. Yeah, so half here, half. Okay. And then let's analyze what the state are. Okay. Okay. Oh no. After we set the buffer, on scroll, right? We add, add or remove the elements, right? From DOM. Not from DOM, but add is DOM. Okay. Remove or add elements as needed. So how should we determine that if we need to add or remove? It must be that the contents area, right? This is the total contents area, but this is, we actually needs a visible contents area, right? This is visible content area. Like suppose there is a 4. Let's give this a black. So these white. Okay, black. This is white. So this is the visible area. Right? So to determine two, we need to compare the visible content area versus the buffer, right? Yeah, so it just becomes clear now. When we scroll, we check the visible content top, the distance here, right? And then check the buffer height and position. Let's say this. Okay. Let's give it some name. Okay, here it should be visible content top, right? Give it here, and this should be should be I'll say it should be what? It should be viewport buffer top. Okay, so this would be, there's a corresponding bottom, and there should be something. No, here should be bottom, top. Okay, this is the viewport. We add some buffer, and here it is buffer bottom. So we scroll, we check these 4 coordinates. Well, so the base should be here, right? 0, 0. And these could be get from the scroll position, scroll top, actually. This is scroll top. And this should be scroll top plus client height. Here is 0. 0. The origin, right? Okay. So this is visible top. This will need to keep track of this by ourselves. And this is the buffer top, could be calculated from scroll top, and scroll top could be directly accessed from the scroll container. This is scroll container plus client height. This is could be derived from the scroll top also. And last one will be maintained by ourselves, right? Yeah, so it's clear now, right? Okay, so for this widget, I think infinite scroll, it have some APIs, right? So what should we do? Okay, let's define the class method, the method, right? Class infinite scroll. What method does it have? Okay, so the first one, constructor, it accepts an element, right? And then a data list. Here, I will ignore the data fetching for now. I'll just suppose that that data is already defined and pass it to our infinite scroll. Okay, so it should be HTML div. I suppose it's div element. This one is data. It should be array item. Items. And here also we need to keep track the render method, right? Render item. Item renderer. Cool. So this is constructor. So what we do now would be something like elements on add event listener, scroll, and we will do what? We will just arrange, I think, call it range, and it should be passive, right? We don't stop the scroll, so passive, true. Okay, so this is it. And these arrange. I'm not going to implement the complete code here. So what the arrange should do is actually checking against the position, right? As we analyze, we need to keep track of the visible content top, and okay, visible content bottom. we could do that, but maybe we could just yeah, let's or we can use the contents visible contents area height. That's better, right? Okay, visible content height. Okay, so when we are rearrange, okay, arrange, but rearrange, what we do, something. If this visible content top is below the viewport buffer top, right? So if this is smaller than viewport buffer top, it means this element scroll top plus this element. Okay, this should not be, it should not be changed. We can cache this one, right? Okay, well, I'll cache it. This scroll top. Oh no. Oh no. This cannot be cached. I'm sorry. So this element top plus this element dot client height. This is scroll top. This is client height, right? So this divided by 2, subtract it. Visible top should be bigger than it, right? Okay. So now we should do what? We should say this append top, because we need more items from the top, right? And we could do the same for the bottom. This append bottom, right? For the bottom. So we need to actually implement this append top and append bottom. The top and visible content height initialize to 0, right? Yeah, at the initial state, the 0, of course, is smaller than the scroll top. 0, this is minus, so bigger than it. So we need append top. But if there's nothing, we should stop, right? And okay, so yeah, append top. We should say if no more, just return, right? If not, we're gonna append the items, right? But when we append the items, this gonna be flickering. The items we're going to cause the reflow, right? Yeah, so actually the viewport buffer top is actually should be controlled by padding. Oh, I'm sorry. This, right? This should be the padding of scroll container. Not scroll, but contains area. But contains area. Okay. Items, and also we set contents area. Let's say here. Contents area. Okay. Append top. Nothing to add. We do nothing. And when we're adding something, if there is something we could add, right? If you add some items, we need to update the visible top content, right? So if we can create the element which would be this item renderer, call these items. The item? I see. The item index. We haven't. Yeah. Okay, we need an extra thing. It's not visible top, but visible item top index. add visible item bottom index, right? It should be initialized to -1, -1. If it is -1, it means there's nothing yet, right? All empty. If no more, it means if the item top index is smaller or equal to 0, then we do nothing, right? And then if it is bigger than 0, we will render one. Okay, append top actually will be trigger. This should be recursive call, right? So I think this should be 1. Okay, 1. I would say here should be while. If it's bigger, we will append contiguously. So we append top 1, we render it, so it should be next. Constant next index, it would be a previous one, right? I should be this, and render it. Items. Wow, I just do some real implementation. I should ignore this. Anyway, the items, and then we do it. We update it. We update the top index. We append, right? Append the item. Append element, and we don't forget to update the visible content top. But here's a problem that when we add it, we need to get to the height, right? So we actually need to append it to. We need to get height, then it should be rendered. Then it's gonna cause reflow. So actually, we should get the height. Okay, the element is this. We get height. So how could we get height? We could create another, like make it absolute invisible. Add it to this container, and or create a similar CSS style, and append it to DOM where is invisible, and then we get the height, and then update the visible content top. Should be the height, right? And then append. Okay, append element. Appends the element, and then yeah, update the top, and we need to update the top. Yeah, update the top. It means update the padding, right? It should be. Where is it? This. Contents area padding top. Contents area padding top equals something, right? Updated the top. So we successfully added item, we updated the padding, and together we set up the visible content top. Now when we append the item with the padding set, it's gonna not going to cause the reflow, I think, but there might be some tricky cases. I haven't tested yet. Okay. Yeah, so this is the add top, and the add bottom should be the same actually. If the visible content bottom is smaller than viewport buffer top bottom, we just add the item one by one until it surpasses the bottom line. And we also update the visible item bottom index to +1, right? Yeah, and okay. Oh, I think I made a mistake here. When we rearrange, I should do some check about removal also. So this actually is not gonna work here, I would say. Okay, suppose we have the remove top one. It should be the reversal of this append top one. Get the top item, get the height, update the viewport buffer top, and then update the padding, and then remove the item, right? And also we have the remove bottom one. It's the same. Get to the height, update the viewport buffer. Get visible, update the visible bottom content bottom, update the index, and remove it. If we remove the bottom, it's not gonna cause the reflow, so it's not that big a problem. So the problem is about the rearrange. So how should we handle it? When we scroll, actually there were several cases. Okay, for the top, it might need more items, or it might have extra items, right? So I think we should check if there is already extra item first. If viewport content top, okay, if that okay, anyway, so if view content top is smaller than scroll top, viewport buffer top is this. Just remove, right? Keep remove top. And for the, if it is small, it's not enough, then we should keep add top. Keep add top. Right? Remove top one. Yeah, the same for bottom. We first check if it is more than we need. We remove it. If not, we append it. So here's the problem that if we say if it is smaller than it, like we're gonna remove it, then after remove it, it might be a case that it might be a case that we after remove it, the visible content top is now below it, right? Then we need to add it, and then it's actually remove it, we add it, so we're done the update in vain. So actually here, I think it should be a thing not visible content top here. It should be a visible content top plus the item, the top item client. Wow, this is disaster. I think. I prefer that this is a coding test. It's not a design. I don't have anything to write here. Okay, something like this. So top item height. This is bottom. So I think that generally I've done it. So I'd like to update about this a little bit. So buffer is okay. We unscroll, add or remove items as needed. Okay, so to determine 2, we will compare actually not the viewport buffer top, but the scroll top here, and we have another one. Top, it should be the bottom of top element, and here should be the top of bottom element. Yeah, so we compare. Here is simple. Now, if bottom of top element, this means the bottom here, it means it could be removed, right? If it's smaller than the viewport buffer top, keep removal, right? Remove top one. And then if it's bigger than it, then we'll add one, right? If the bottom is smaller than okay, if smaller than it, then we do nothing. But we actually when we add something, we need to check the visible content top actually. So if visible content top is bigger than viewport buffer top, we keep at top one. Okay, now the same for the rest, for the bottom. I'll skip it. So this is our general idea. Buffer and scroll. Okay, this is the interface. And this is what we need. Visible content top. These are 4 variable here. So what's the bottom? What's the problem here? I think there's a problem that maybe rather than we get the element height direct from the API, the client height, we could cache the height when we. Okay, I'll write down the improvement. Improvement. Possible improvement. We should actually memorize the height of each item. So that we could do purely mathematical, right? We don't need to fetch the attribute or get the client height of each item. That will actually hurt the performance. So we could memorize the height of each item and do the calculation purely, right? The second one, yeah. Second one is about the data fetch, about this data source actually. We are supposing that we get the constant data list. There's no API call here. So actually we need to improve that. I think it should be append bottom here. It should be add API fetch logic in add top and bottom one. Yeah, so that's we need to keep track of the data source, if it is fully fetched or not. That's a different problem. We should create another class, a data source, and say if there is not enough, there's no more, like if no items are all rendered, and data source is not fully fetched, we should fetch the API, right? We should fetch the API, and render. Fetch the API, update the data source in items, and then try this again. So it should be async. I would say this better be async. Yeah. We should avoid calling this when we're already calling the API. So we need to keep a flag here. I say if data source is fetching, we should return, right? Yeah. Something like this. Memorize the height of each item and yeah, fetch the data of the bottom one. The tricky part is about the get height of the item. I would say just to set the. Is there a better way of doing this? No. I'll just say get the height before we insert the DOM. Yeah. Or if we do something stream, we could just implement the scroll totally by ourselves. Well, that becomes that we need to or handle scroll by ourselves. This is possible. I tried something about like this in my manga viewer several years ago. It's actually not that difficult, but just need to be careful about the inertia to make the scroll more natural as possible. And if that's the case, actually we'll keep the scroll position, not the scroll position, but actually a transform, right? The coordinate. And even if we add some elements, the transform won't change. Or not. Wait a minute. Oh no. Oh, this is not good. I should not say this because we always wanna add these items to the DOM. When you insert something here, it definitely gonna cause reflow from the bottom items below, right? So okay, so this is the design for this infinite scroll. Okay, so last one. Lazy load everything. No, not everything, but media in item, if there is any. So if this image, if it is out of the here, right, out of the scroll container, but in the buffer, we could still lazy load that, right? When we scroll view to it, when we scroll it into the scroll container, which is visible to the user, we could show the image. Well, this is it. Okay, hope it helps. I think I made a mess about the implementation here. Well, if this is not a product design, it's like a small feature. I think writing something like this is much more easy to understand. But I should make it better about here. Yeah, buffer. Okay, on scroll need determine two, and then I should write this method before I write the exact implementation. Let's rewrite this part. Okay, the first thing is that we accept constructor accept element contains area data list item renderer. So set up, and then as we analyze, we need to keep track of the viewer port buffer top, right? Oh no, we should do visible content top. And then we should keep track of the visible content height. And then visible content top item index, right? And we need to keep track of the top one, bottom one also. This is the bottom index. And we should have a method called rearrange. In rearrange, you will check all these coordinates. Scroll top could be get, client height should be get. Okay, these four. And then, if it is have more items than we thought, we should remove top item. We call this recursively until that is only the minimum items we want. And then we have also add top one, right? And then we have remove bottom one, and then add bottom one. So this could be better, right? This is like the class, the interface of this class. Yeah, and then combining together with this part, this brief explanation, I think the interviewer could understand what we're doing and then improvements. Yeah, that's it. So this is a simple one. Hope it helps. See you next time. Bye bye.